Hi everyone! Today we're going to talk about quadratic functions written in vertex form. Please make sure to write the FLT for today. Given a quadratic function in vertex form, I will be able to label the different parts. So what do quadratic functions written in vertex form look like? For the past few lessons, we focused on quadratic functions written in standard form, where f of x equals ax squared plus bx plus c. Today, we're going to rearrange this and write it in vertex form. So the vertex form is the same as the standard form, just written differently. So our vertex form is f of x equals a times x minus h quantity squared plus k. And here, h is actually equal to negative b over 2a, but you don't exactly have to remember this. It's just a quick note. Right now, we will not be looking at how to convert from standard form to vertex form. Just know that they are the same thing, written differently. For example, this graph is represented by the equations on the right. So in standard form, we have y equals 2x squared plus 4x minus 5. But if we rearrange that, we can write it in vertex form, where we have y equals 2 times x plus 1 quantity squared minus 7. We're first going to focus on identifying the different parts a, h, and k of quadratic functions written in vertex form. So here's our first example. Identify a, h, and k for this function. F of x equals 2 times x minus 3 quantity squared plus 4. I'm going to write the general vertex form right under it to see if we can simply match and replace the letters or the parameters with the numbers. So we have f of x equals a times x minus h quantity squared plus k. To identify a, h, and k, we need an exact match. It needs to look exactly the same. So we need an exact match, kind of like Cinderella's shoe. Notice here we have an exact match. So a is replaced by 2, so we know that a equals 2. H is replaced by 3, so h equals 3. And k is replaced by 4, so k equals 4. We identified a, h, and k. A equals 2, h equals 3, and k equals 4. For our second example, let's identify a, h, and k for this function. F of x equals negative 3 times x minus 2 quantity squared plus 8. I'm going to write the general vertex form. So f of x equals a times x minus h quantity squared plus k. What are a, h, and k replaced by? A is replaced by -3. So I know that a equals -3. H is replaced by 2. So h equals 2. K is replaced by 8. So k equals 8. Since it was an exact match to the general form, it was pretty simple to find that a equals -3, h equals 2, and k equals 8. On Edpuzzle, please identify a, h, and k for this function. F of x equals 5 times x minus 4 quantity squared plus 7. Next, let's identify a, h, and k for this function. G of x equals 6 times x minus 3 quantity squared minus 2. Let's write out the general vertex form. So g of x equals a times x minus h quantity squared plus k. Notice here, we don't have an exact match. For our general form, it's plus k, but in our function, it's minus 2. So let's rewrite this so that it's an exact match. So rewriting it, I'll have g of x equals 6 times x minus 3 quantity squared plus -2. Subtracting 2 is the same thing as adding -2. Now that we rewrote the function, notice that we have an exact match. So we can now easily identify a, h, and k. So a is replaced by 6. So a equals 6. H is replaced by 3. So h equals 3. And k is replaced by -2. So k equals -2. We found that a equals 6, h equals 3, k equals -2. Make sure the function is an exact match with the general vertex form before identifying a, h, and k. So on Edpuzzle, please identify a, h, and k for this function. G of x equals -2 times x minus 5 quantity squared minus 6. Notice that you will have to rewrite the function so that you have the plus k part. I want to make a quick note before we move on to the next examples. So remember that a double negative turns into a positive. For example, -3 is the same thing as +3. So the double negative turned into a positive. And the other way around as well. Positive 3 equals negative 3. So if I had something like 4 minus negative 2, the double negative turns into a positive 4 plus 2, which equals positive 6. With that in mind, let's move on to the next example. So identify a, h, and k for this function. J of x equals 3 times x plus 7 quantity squared plus 4. Let's first compare this given function with the general vertex form. The general vertex form would be j of x equals a times x minus h squared plus k. Notice right here the minus and the plus, so we do not have an exact match. We have to rewrite it. But how? Think about double negatives. So positive 7 is the same thing as negative 7. So let's use this to rewrite our function. J of x equals 3 times x minus negative 7 quantity squared plus 4. X minus negative 7 is the same as x plus 7. We just wrote it differently so that it matches the general vertex form. A is replaced by 3. So I know that A equals 3. H, since we've rewrote it, is replaced by negative 7. H equals negative 7. And K is replaced by 4. K equals 4. So after we rewrote the original function, we know that A equals 3, H equals negative 7, and K equals 4. Let's look at a similar example. So identify A, H, and K for this function. J of x equals 6 times x plus 1 quantity squared minus 4. The general vertex form is j of x equals a times x minus h quantity squared plus k. Notice here the plus and the minus, over here too, minus and plus. It's not an exact match, so we need to rewrite it. Notice that positive 1 can be written as negative 1. We would rewrite this as j of x equals 6 times x minus negative 1 quantity squared plus negative 4. I had to rewrite the h and k parts to get an exact match. Now let's find A, H, and K. A is replaced by 6, and we have a equals 6. H is replaced by negative 1, so h equals negative 1. K is replaced by negative 4, so k equals negative 4. After rewriting the given function, we found that a equals 6, h equals negative 1, and k equals negative 4. On Edpuzzle, please identify a, h, and k for the function j of x equals negative 2 times x plus 3 quantity squared minus 9. For example 9, let's identify a, h, and k for this function. M of x equals x minus 4 quantity squared plus 6. Do you notice that we're missing anything here? Let's take a look. The general vertex form is the following. M of x equals a times x minus h quantity squared plus k. Notice in our given function, we're missing this a value. Right here, there's actually an invisible 1. Similar to how we write x rather than 1x. So I know by this that a is replaced by an invisible 1, so a equals 1. H is replaced by 4, so h equals 4. And lastly, k is replaced by 6, so k equals 6. In this case, a equals 1, h equals 4, and k equals 6. In this case, a was an invisible 1. Next, let's identify a, h, and k for this function. M of x equals 5 times x minus 3 quantity squared. What are we missing here? The general vertex form is m of x equals a times x minus h quantity squared plus k. This plus k part is missing up here. What do we use to symbolize emptiness? A 0. So we have that a is replaced by 5. So a equals 5. H is replaced by 3. H equals 3. And in this case, k is replaced by the emptiness, the 0, so k equals 0. A equals 5, h equals 3, and k equals 0. Remember, we use 0 when we see emptiness. Here's our last example. Identify a, h, and k for this function. M of x equals 6x squared plus 8. What is different here? The general vertex form is m of x equals a times x minus h quantity squared plus k. So we have this x minus h in the parentheses usually. Where's the parentheses? Where's the minus 8? It's missing. Something to note here is that h is inside the parentheses with x. So h is bundled with x inside parentheses. So we're going to use 0 to symbolize emptiness and rewrite this given function. So what would this look like if we rewrite it? M of x equals 6 times x minus 0 quantity squared plus 8. A is replaced by 6, so A equals 6. We rewrote the function, so we know that h equals 0. And k is replaced by 8, so k equals 8. So A equals 6, h equals 0, k equals 8. So for h and k, if you see emptiness, think of 0. So just as a review for today, the vertex form of a quadratic function has this form. F of x equals a times x minus h quantity squared plus k. When identifying a, h, and k, make sure your function is an exact match with this vertex form. Please remember to submit notes on Canvas and see you next time.